All right. So last stream, turns out that none of the screen wasn't recorded. It was just like frozen at the first thing. It's happened once before. So now what I'm gonna do just while I'm streaming is I'm just gonna like wiggle the terminal around and like verify that it's moving in the stream. So that's good. So no problems. Wait, hang on. I thought I heard something. Oh, whatever. Wait, no. Never mind. So yeah, so last stream, let's just like go over like what actually happened. So basically so like what I did last stream, well first of all I started off a leak code question, so let's refresh this. So like I started off by doing line reflection, and that took me like a bit of time to solve. Pretty good solution, I must say. And then well this I just did right now, but I started off doing that, and once that was finished, what I did was I did basically get discretized coordinates. Wait, let me just shrink this down and wiggle it a bit to make sure that it's wait, what? What does that mean? Never mind. So anyways, the whole point is that last stream I basically did this, get discretized coordinates, and I used these two console.log statements that I'm highlighting. Well, I mean, I took like from 3, I tested 0, 1, 2, and 3. I printed out like with this console.log to like kind of, because like initially like the whole image stack printing out, like it takes too much space. It was like what, like 1,200 0 or 1 entries. So that's like a lot of numbers to look at. So I did it like image plane by image plane. So basically all I did was I kind of like, all I did last stream, which was again botched, was I just kind of like I just implemented this. And then the way I implemented this, I actually talked about several streams ago. Like the moment I switched from Connect 4 to BumperCoins, I talked about game state discretization, or a game state representation, like how we represent the game state for inputs in our neural network. Like it's a real time. I mean, it's a like the x and y coordinates and the like velocities and like all the numbers are real numbers. I mean, like they're floating point. Like, well, 64-bit. Like the point is there's a fraction, whereas neural networks like just it has to be kind of discretized to, so then like here's like the formula for actually like given a coin, like given the x and y coordinates, like here's how we discretize them, and that's what it returns. It returns the row coordinate, column coordinate. So like now basically the whole point is like the whole point like that I've been working towards quite lazily, I must add, is basically discretization or game state representation. How to take in a game state, a BumperCoins game state, and convert it into an input that the neural network can digest, right? So like just like in Connect 4, we had a. I'll just do. I'm basically doing a recap of last stream because it was kind of messed up. But yeah, so like here's like the whiteboard which I was showing. So like, oh yeah, that was like this whole stuff before was just for elite code stuff. It's kind of a shame that it was missed because I was really pleased with the progress that leak code question, because it actually had a lot to do with this game, like particularly symmetries, like when we're doing symmetries for BumperCoins and Connect 4 reflecting about a line. Like BumperCoins has extra symmetries that Connect 4 doesn't have. Connect 4 only has one symmetry, like flipping about the middle vertical axis. But anyways, like the BumperCoins has that plus the horizontal axis too. Right. So where was I? Basically, like they're basically four, like, never mind. Wait, let's just kind of redraw it. So like like a game state, right? Just a refresher. Like initially, like let's say that this is our game state, right? We have like player one's king coin, then like player one's non-king coin, player one's non-king coin, and we have like player two's like the same things. Where let's pretend that everything is nice and centered. Where again, everything kind of approximates like you see how like it's like kind of like they form like angle brackets, like the initial formation looks like this, like these two brackets, where like each kind of edge is like a coin, like a king coin, non-king coin, non-king coin, 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 just like how like we kind of get all that. So like that's kind of how like this looks like. Oh, I forgot obstacles. Okay, yeah, good thing I didn't say. Anyways, so like basically for a given player, like this is like P1, and that's like P2, or not P1, P2. I should say like P current, like player whose turn it is, and like just P other or P non-current, whatever. Or just, yeah, P other, whatever. So the point is that like we first do the current player whose turn it is, and then in terms of coins, that takes two coins, right? Or that will have like two planes, right? So the first plane will kind of look like this. It'll have like kind of like an entry here, which kind of maps to like this coin right here, which is like the king, which is, so it's like, so this plane is like the P1, like the P current king coin. And then the second plane is P current non-king coins. The non-king coins. Let's just call it other. Right? So this plane will look like this, or sorry, let's kind of like show that it's kind of shifted there, like this and like this, where they correspond to like to this coin and this coin. This is very similar to like a Connect 4. And then we basically like do the exact same thing. Like we have two more planes, and those correspond to the other player. The other player's king coins, and the other player's other coins, non-king coins. Like that. And it'll look something like this, and then like kind of like that, and then like you can't see it, but there'll be one more dot underneath there. So anyways, that's the basic idea, right? So that's like kind of what I was drawing last time. So like when we actually look at it, right? Like when we, so like basically like let me just uncomment out this let me uncomment out, so basically, yeah, wait, no. Let's just do image stack.length, right? Because there's 4 planes. You can see that here, which I'm highlighting in line 9. Like these 4 things, just like to see 4. And let's start off with the first one, right? Compile it, and then let's clear everything because we need lots of space. And let's just node it and run it. So as we can see here, right? So like this is basically like what we're working with is just this thing right here, right? Like a coin centered here, a coin centered there, and a coin centered there. And then we start off with the king coin, right? So I basically like did the math already, like last stream, which again was botched. But the idea is we'd have like 7 1, 2, 3, 5, 6, 7. Like that's like 15 rows. Each row has 20 entries. And then the idea is like this would be in the 7th row, and like the first one there, because like if you look at like this thing, right, like one, like all zeros, like 1 2 3 4 5 6 7, and then it snaps to this one, so there'd be 7 rows of zeros, and then the row of interest, which has the king for player 1 or the current player, and then 7 more rows of zeros, like 1, 2, 3, 4, 5, 6, 7. So it should look like this, like 7 rows of zeros, the king coin, 7 rows of zeros, where the king coin's second entry, right? So that's what happens. Like this, it's 4 because there's 4 image planes, and here's the first image plane, which is the current player's king coin. So 1 row of all zeros, 2, 3, 4, 5, 6, 7, and then you see this 1 that denotes the king. Now note that this 1, it's not a binary 1 or 0 like Connect 4 representation is, but rather this 1 is actually the coin's health. So this just means that the king coin has full health. That's it. It could be a decimal too. And we have 7 more rows of zeros below. 1, 2, 3, 4, 5, 6, 7. Okay, good. So then, and now let's do the same thing, but let's delete this console.log. And now let's go to the next one, right? So prediction time. So then before I click return and run this, now what we have, so then we just did the first thing, which like we kind of saw the 1 for that, which is the second entry. Now we have these 2 coins, which are the non-king coins, and then they should be the third entries in the respective rows, and there should be 4 rows of 0 from the start and from the end, and those should be the only 2 rows with the 1 in them. And we can see that like right here, like this one kind of like, because the king snaps here, we kind of snap those 1 further. So it's like 1 row of zeros, 2 rows of zeros, 3 rows of zeros, 4 rows of zeros, and then the non-king coin right here at the third entry. Then 1 row of 0, 2 rows of 0, 3 rows of 0, 4 rows of 0, 5 rows of 0, and then same thing. And then 4 more rows of zeros, 0, 0, 0, 0. So we should have 4 rows of 0, then 0, 0, 1, a row with the 0, 0, 1 third, and then 5 rows of zeros, 1, 2, 3, 4, 5, and then another, same thing to denote this coin 0, 0, 1, and then 4 more rows of all zeros. So then we run that and we kind of double check it. So initially 1 row 0, 2 row 0, 3 row 0, 4 row 0, and then 0, 0, 1, which kind of corresponds to the 0, 0, 1. That's where we want it to, like, that's where we want this coin to show up. And then we have 5 more rows of 0, like 0, 0, 0, 0, 0, 5 more rows of zeros until the next 0, 0, 1. So then 1, 2, 3, 4, 5. These are 5 rows of zeros we've just cleared. And now we see the again 0, 0, 1, which is the second non-king coin for the current player. And then 4 more rows of zeros. 1 row 0, 2 row 0, 3 row 0, 4 row 0, and that's correct. So basically, like, this whole thing, like, and then we can like do the same thing for the other ones, right? Like we can do 2 and 3, but basically you can take my word for it that they kind of denote the other waiting players or the other players, not the current player whose turn it's not to go. So like we can just kind of like take that for, yeah, you can just trust me on that. So that's what I did last time basically. So there's no need for logging these statements anymore. Status, get diff, just delete the 2 comment. Okay, fine, just add that. Okay, so now I have some notes that I wrote. So basically this is what I wrote yesterday. So today's stream, historical prev game state as well to encode velocity. Or actually, let's start from the top. Fix to update game state. Yes, I did that. I use an apply move. It's untested, so we can actually test it maybe today if there's time. What else? So do historical stuff like previous case states. We're about to do that. Hard code for 2 for now. Let's delete that line because it's taken care of. Maybe no need. Here's a kind of a note. Just add that as a note from last stream or maybe some other stream previously. So save this. So next stream, which is today, historical prev game state as well to encode velocity. I mentioned this before. First review changes from botched last stream and maybe do console.log prints in each of the images stacks again. So I did half of them, like the first 2, just to show the king and non-king for 1 player. So that's done. Then I think set num game states to 2, meaning encoding should store both current and prior game state. So it's like the k equals like the historical k stuff, which I deleted, separated by around 30 ticks. Can adapt. Okay. Here's some implementation details I was thinking of. I was pretty excited about this. Well, not excited, but I was pretty like, I was like, yeah, it's a cool idea. Just generalizing what we already have. So I can like, no need to go over this right now, but basically, yeah, so basically like, just like we have like 4 planes, this is from last stream, but we do the same thing, but for the prior game state. So just like we have 4 games, like 4 planes to like kind of show the coins, what we also need to do is we need to have like 4 more, like we have like 1, 2, 3, 4 planes. We need like 4 more planes doing the exact same thing. Like this is for the game state current, and then we need like the game states prior, the old game state. So basically like again, like so like basically so if you draw a line here, like everything below this line has been from this stream, and then everything from above this line has been from the last stream that wasn't recorded. But basically like what I'm saying is like say we have a coin here, like a coin here, right? This is a black coin, right? And it's going like with some velocity to the right. That means in the prior frame it was probably like a bit to the left. So like if we're storing like the past 3 frames, or like we're storing like k equals 4, like we're storing 4 like historical data, then like in one plane we'll see the coin here in the past, then the next plane it kind of inches to the right by a bit, and then it kind of inches more to the right in the third plane, and then the fourth plane. So like as you can see, the coin like kind of is migrating like more and more to the right. So like so that's kind of like encoding some velocity by storing historical data. You can kind of look at the deltas. The neural network can like kind of get a hint at the velocity of the coin. So that's how we kind of store it. So I'm thinking just do it for 2 for now, but we'll see. I just want to make sure I talked with this before that like when you apply the move, we should see a change, or else we have to change the number of ticks, or we have to change something, the energy stuff. But anyways, let's work like let's what's that saying called? Cross the bridge when we get there, right? Okay, so let's get started. I'm thinking just like like only store like 2 game states in our representation. Store the current one and the past one. So okay, let's do that then. And let's get the game state.ts. So one thing I think we can do is in game state, what I was thinking of doing is we can actually make it kind of like a linked list. Like we can also like maybe like store the previous game state. So like that. Now I'm not sure if we can do circular reference in the constructor, but if I can't like Google it quickly, then I'll just forget it for now. Kind of like a disjoint set, like the disjoint set or union find technique, where like there's a sentinel or like a root where like its parent is itself kind of thing. Typically like in Java, at least the way I implement it is I have a static function that kind of returns it, the root, like called make root or like make node or something. But wonder if we can do it in the constructor. Oh, whatever. Forget it. Let's pretend that this is set and that's not undefined. Or if it is, we can handle it separately. Whatever. So, okay. What did my note call it? Let num game states number equal to 2. We can actually dynamically generate this image stack. Let's delete that. For let I 0, I is less than the num game states times 4. And then 4 is basically like, because like each game state takes 4 image planes to kind of represent it, right? So if it's 2, then we'd have like 8 and so forth. Image stack dot push an empty thing, just like that. So now we're kind of like doing it dynamically because we're not hard coding that, so that's great. Okay. Okay, everything's all zeros. And I see how we have let coin of game state.coins. Now we change it to like nest this in. For let game state. Let's call this GS of or no, it's like a linked list. For int I equals 0, I is less than num. Let's call it k for the kth game state. K equals 0. For let k equals 0, k is less than num game states. K plus plus. So do this k times. Game state. Advance game state to prior. And then here, if game state equals or game state equals game state dot what do they call it? Prev game state. Actually, let me use a different variable. Cur game state equals to game state. And then cur game state is that. If that exists, if it's undefined, or else it's itself. It's that, or else just the same thing. Just like that. And how do we do it like Vim, like how do we do it in like some lines? %s %s game state cur. Actually, wait, no, there's only one reference, right? Just this. Just like that. And nested in there. Okay, so then for each, basically, k equals 0, so then like we kind of like do it like 2 times. For the coin of the current game state.coin, the feature is the game state dot is, so then this is 0 or 1 for, it's like 0 or 1 for like the current or other player. And king feature, okay, fair enough, it's binary 0 or 1. And image in this, so this has to change, right? Now we have to take into account like if now we have to take into account like which player we are. So again, the size of that is 4, and like the size of this is also 4. So like if we're in like, let's say like the second thing, right, which is index 1, like the second one, that's just 0, 1, right? But the second one here is like we have an offset of 4. So like the actual offset now is basically like, see how we have like similar offset, like recursive offsets. Like we have another offset, right, which would be like 4 times, again, 4 is like the same thing as this, right? Like this, the like 4 images in the image, like each game state's coins takes, like to specify coins for game state, we need 4 image planes, like these 4, right? So like that's why we have to multiply that by 4 for the offset. So 4 times num game states. No, sorry, no. 4 times k, right? Plus like that. 4 times that, so like 0, then it just becomes this, like the first 4 would just become that, which is the current one, and then you advance it plus, so everything is offset of 4, right? Like for the second time, like we go 0, 1, 2, 3, and then 4. So like we kind of like shift past the first 4, which is why that works. Just like how we have like 2 times that, like it's like hours, minutes, and seconds kind of thing, right? Like hours multiplied by, or like for seconds, if seconds are 1, then minutes are like a factor of 60, and then like the hours are a factor of like 60 squared in terms of seconds, right? Like you have 2 here, like this 2 comes from like the cardinality of like how many options for king feature, like 2, and then for like this 4 comes from like this 2, where it can be 0 or 1, and then like this feature here is card like 0 or 1. So it's like, if I have my notes summarize that, right? Adapt current function by adding a new feature like that. Okay, I'll show you. Let's just do that. Never mind. Basically, like this k is like the historical feature, right? Hang on, I hear some noise in the outside. Let me check what's going on. Nope, that was just the mail delivery guy. Just finished my water. Okay, so we have our image index, right? And then we get our coin coordinates. I think everything is the same, right? I think we've successfully adapted our logic of that. So let's bring back our console.log statements. First, to make sure it's 8, because 4 times 2 is 8. Let's do the rest. Good, no errors. 8. Okay, so now let's review that. Let's review it. Let us review it. Let's go row by row then quickly. Actually, let me quickly do get status, clear, get diff. Let me just add everything first. Just like look at my diff. So in game state, we're making have a linked list. We're storing a back pointer to the previous one. A reverse linked list where linked list store next pointers. This one is like reverse that, stores back pointers, backtracking pointers, traces, whatever you want to call it. The num game states we hard code to 2, just because like 2 showcases the main minimum, right? Like it's more than 1. That's the main thing. It's the smallest number more than 1. Basically, my kind of design philosophy is like keep things as simple as possible, but still enough to encode some information. Like we're somehow capturing the velocity dimension by this. I hope. Everything is like suffixed by I hope, appended onto it, implied, implicit, whatever. So now we have like, instead of like kind of hard coding to 4, now it's like dynamic based on number of game states. So you have to multiply that by 4, and then we kind of like do that. And then we just make this inside a nested loop where we do it like num game states times. And then the whole idea now is our image index. In fact, like I'm so happy like we have this notion of features to like kind of like just basically like, because of like the way this was designed, rather than like hard coding everything, but whereas dynamically generating the image index based on like the feature, like it's hours, minutes, seconds. Like we have minutes and seconds, and now we're just kind of like sticking in an hours notation to it. So like this dynamic image index kind of thing code, which I had last time, it's quite like really nice how like this was 2 streams ago, so like this one was not botched, so that's kind of nice. Like it's really nice how like with minimum changes I hope that I implemented. So let's just add this and then we advance it, right? We advance it if it exists. If this pointer points to an actual game state, that's what the question mark is, some JavaScript or TypeScript weirdness, where it's like things have truthy or like falsy values, I think. So like if it exists, then we if it's not equal to undefined, if it exists, there's a shorthand for that. Then we set it to like the previous one, or else we leave it itself. Okay, so that's good. Let's just do a get add that. Get add net.ts. Get status. Okay, let's just do get add game. Let's do get add all. So get status. Okay, good. Now let's clear and run it, right? Oh wait, yeah. Sorry, we have to make a change, right? So now let's like now we have 8, right? So now instead of doing now we know it's 8. Let's like kind of step through, right? First one is 0. So again, what's the idea? 7 0 rows, then the king coin, and 7 more rows, whereas king coin is second entry. Let's see. 1, 2, 3, 4, 5, 6, 7 rows of zeros, the king coin, and then 7 more rows of zeros. 1, 2, 3, 4, 5, 6, 7. Correct. Now let's verify it for the next one. So now what do we expect? 4 rows of zeros, 0, 0, 1, 5 rows of zeros, 0, 0, 1, 4 rows of zeros. So 1 row 0, 2 row 0, 3 row 0, 4 row 0. Good. Then 0, 0, 1 for one of the non-king coins. Then 4 rows of zeros. 5 rows of zeros. So 1, 2, 3, 4, 5. Correct. Then 0, 0, 1. And then 4 more rows of zeros. 1, 2, 3, 4. Correct. Okay, I'm just speed running this. And then same thing, but now 2. So this is basically like what I did not do. I mean, what I did last stream, but not this stream. I'm like kind of going over the remaining ones. Like now we kind of like what we're expecting is we're kind of like we want to see these 3. First we see this one 7, and then a bunch of zeros, and like the second to last, like 19th or 18th if you're 0 indexing, like the second to last would be a 1. It would end in 1, 0, like 7 rows of zeros, something ending in 1, 0, then 7 more rows of zeros. So we can just see that one in our third thing. So 7 row 0, 1, 2, 3, 4, 5, 6, 7. And then we see like all bunch of zeros ending in 1, 0. So the king is second to last, which is what we expect, like from this thing here. This kind of like snaps, discretizes to that one. Second to last, right there. And 7 more rows 0. So 1, 2, 3, 4, 5, 6, 7. Correct. And now let's see the fourth one. because 0 index, the fourth one is denoted by 3. Four, 5, 4, right? 4 rows of zeros. 1, 2, 3, 4. Then we see 1, 0, 0, which is what we expect, like third to last. Then 5 rows of zeros. 1, 2, 3, 4, 5. Then same thing, third to last. Then 4 more rows of 0. 1, 2, 3, 4. Great. And now, so that's the first 4. And this is length 8, right? So now what we have to do is we have to kind of repeat this, right? R4, the next one. And this should be the same as 0, right? This should be the same as just the king coin, which we already saw. Seven rows of zeros. 1, 2, 3, 4, 5, 6, 7. And then the king coin for the current player, and then 1, 2, 3, 4, 5, 6, 7. Perfect. I don't think we need to do the rest. So now what one thing, okay, so that's actually a good start. Status. Okay, so that's fine. Or let's just step through it just for completion's sake. It'll be very redundant. We're just like repeating those again. What we already saw, we're gonna see again. Just why not? One, 2, 3, 4, and then 0, 0, 1, then 5 more zeros. 1, 2, 3, 4, 5, and then 0, 0, 1, and then the other non-king coin, then 4 more zeros. 1, 2, 3, 4. Okay, correct. Next one, because we're almost done. We only have 2 more. So this is the king coin from the right side. And there should be 7, then ending in 1, 0, then 7, where 7 means 7 rows of zeros. Right? 1, 2, 3, 4, 5, 6, 7. 7 of all 0 rows, and then the king coin ending in 1, 0, so it's very close to the right. Correct, which refers again to like this one right here. And 7 more rows of zeros. 1, 2, 3, 4, 5, 6, and 7. Okay, and then now for the last one. Four, 5, 4, where the ending is 1, 0, 0, correct? 1 row 0, 2, 3, 4, and then we have something ending in 1, 0, 0, which is the other coin, like the not current but the waiting player whose turn it's not, and then like his non-king coin 1, 0, 0. So it's not as close to right, but still pretty close, like one further away from the king. And then 5 rows zeros. 1, 2, 3, 4, 5, and then again 1, 0, 0, and then 4 more rows zeros. 1, 2, 3, 4. Okay, good. So our image stack is successful. So we can actually note we have not taken into account obstacles. I'll do that later. That's not so important. I feel the coin coordinates, but basically like with all these zeros and ones, again, it doesn't have to be 1. 1, it just happens to be full health. The health is like between 0 and 1. It could be 0.5 or whatever. Like its brightness, so to speak, its vitality is captured in this number. It's kind of nice that's already regularized, normalized from 0 to 1. So that's pretty cool already. Oh, I'm out of water. So yeah, so now the next thing to do is actually to like kind of, I noticed that like we need some changes and to implement apply move to make this change and make other changes. Unsure can, yeah, I have a nice comment here. It kind of reminds me of prefix sum or prefix multiplication, how we have like you have seconds, then minutes are 60 of that, like a times 60. And you have to times by 3600, 60 squared. So it's like prefixes of like powers of 60 or whatever. So it's like prefix multiplication instead of prefix sum. Just a neat idea. Anyways, so yeah, we basically did this, and now like it's now the historical stuff we've kind of like done in terms of representation. But now we have to implement apply move and actually test it out. Cause like notice that like when I console.log like the game state itself, like the previous one was itself, but now we want to like apply the move and like actually like take a coin, launch it a bit, and then look at how it actually changes. Like maybe like if you're launching this coin to the left, then maybe like it'll like change and become a 1 here instead. Like we can like look at the shifts in 1. Like we can kind of look at the we can kind of look at these changes here, right? So that's kind of like my idea now. Maybe we should like kind of work on apply move, because apply move, right? Like now that we added a new field to game state, like if we like kind of look at our get diff stage, I think it's just s work, whatever stage of game state, right? We added this new field, but when we're actually applying the move to the game state, like we have to kind of handle this stuff. I think we might have to implement clone first too, right? We might have to like clone a snapshot of our game state and like do some pointer mangling. But yeah, for now at least, I mean, for now we can at least print like not only print the game states coins, but we can print coins, historical coins too, like prior coin positions and previous frames. Now technically a frame, like a tick is like, frame is like about 30 ticks. Like we're advancing, like we're basically like made this a turn-based game instead of real time. So it's like time skips of 30. But anyways, the point is like there's been some work done for now. I think the apply move, like, yeah, like this comment right here, implement a apply move to make this change and make other change. Unsure if can finish. Yeah, I'm getting bored, so I'll just kind of like stop here because I implemented like, so what I've done today, just this stream, is implementing like discretizing like the game state representation for coins, but extended it not just to be like the current coins discretized coordinates in our image for our stack of images, but also like the historical, like past, like also the past coins too in the prior frame, the prior game state. And then I made that generalizable where we can like store like k prior, like some num game states. Like we can like kind of give it some past coin position information too, to hopefully like, and yeah, basically to encode velocity. So yeah, I guess like generally like the stuff here which I wanted planned out has been done pretty quickly, but I'm just gonna end it. So yeah, that's all for now, I guess. And next time we're gonna work on the apply move to actually like when we apply the move, we have to actually like do some like whatever, like we introduced a new field, so we have to like kind of consider that, make some changes to like populate this previous game state when we make the move. So yeah, apply move is now going to have to like do some work on this previous game state. So that's all for now. And yeah, note, I think we'd have to implement game state dot clone just like in C4, just like I know C4 has it. C4 has clone as well, used during the MCTS, right? Used during, how many nested parens do I have? Used during MCTS, a leaf node case. Close this bracket, then close this bracket. Actually, no, we could implement clone to capture snapshot of current coin positions and of current game state, and then when we apply the move, so we basically have a game state and it has like a linked list that points to previous ones, but when we make the move, right, like we have like, so like when we do apply move, like we have like our current game state, which is like our GS pointer, and like it points to like GS previous, right? And this is like game state, like this is our game state, like just GS for game state. Like that corresponds to like that, and then we have like another one like GSPP or whatever, like GSPP. Then like when we apply the move, what I'm thinking we're gonna do is like take this GS thing and kind of make a copy of it that also points to the previous one. And then what we do is we take like this one, like we sever this connection, and we actually apply the move onto it, like we'll apply the move, so now it'll like be like, this becomes like GS next. GS next. That's a G. Trust me on that. And then we take our next and we kind of take this break that link and kind of like point it to like there. So like that's kind of like a clone of the original GS. And then GS remains, like GS still points to this object. It's just we kind of like if we, actually that looks all good, but basically like if we have like this, like we have like this, and we're at here, GS, and then we were to actually like apply the move and like make it like next, then like we'd kind of like skip, like we don't want to skip the current one, so we have to kind of store that. This feels wrong, actually. This feels wrong. Maybe I'll think about it some more off stream. But anyways, for now, at least like we got the whole like, we're able to at least like, you know, like capture the coin's positions, both current and historical. So I guess I'll, yeah, again, end here, but next time some work on apply move. And possibly note is possibly, I think we have to use clone. Whatever. Yep, that's a fitting end.